For the next couple exercises, we're going to chop up triangles in different ways. This first one is we're going to be using perpendicular bisectors, which you can probably guess what that means from the name. But essentially, it's a line that cuts another line in exactly two equal parts, and is also at right angles to it. So how do you draw a perpendicular bisector? So over here on line AB, step one is to find the midpoint. So let's call that M so that AM and BM are equal. And then from point M, erect perpendicular. That's it. So what you're going to do is with the different triangles on the first page that says perpendicular bisector, you're going to do it to all three sides of the triangle. So again, you're just going to follow those two basic steps, find the midpoint. You don't have to make the tick marks. I'm just doing it for our purposes here. Erect perpendicular. Just go ahead and extend that, way out of the picture just to make sure it looks all right. And then, go to the next line, find the midpoint approximately here, and erect perpendicular. All right. And you're going to do that for the third side. Now, for these exercises, you will get better results if you're very careful with the drawing. So I did this kind of haphazardly, but when you're doing it, get out a ruler, measure how long this is, and then find, let's get that glare out, find the midpoint of that line as best you can, and then, using a straight edge, draw that perpendicular line. Same thing here, and then to the third side. You'll notice that something curious happens when you draw all three perpendicular bisectors. Do that for every triangle on that first page. For the next chopping exercise, another bisector, we're going to do angle bisectors, which again, the name of it should make it pretty obvious of what that means. But essentially, given an angle, like angle ABC, you can find the angle and draw a line that cuts the angle into two equal smaller angles. All right. And my advice for drawing these angle bisectors, again, use a protractor to get it as accurate as possible. But maybe use the protractor to draw a nice little curved line, and then measure kind of how big that is divided by 2, and then you should be able to find them halfway through that arc and be able to draw a line so that you're creating two equal smaller angles. All right, so that's what an angle bisector is. You're going to do that for all three angles in a triangle. So come to the first angle, using a protractor, and extend it through your picture. Extend through your picture, etc. And once again, once you do the third one, you'll notice that something curious happens. The more accurate your drawings are, the better results you'll get. You'll start to notice the trend of what should be happening, and if your lines are off, you'll notice they won't quite match up. For the third way of cutting up a triangle, we're going to be drawing medians. Now, we don't know what a median is just yet, but it's pretty simple. The three easy steps. First, just pick a side and find the midpoint of that side. So if we start with BC, we're going to find his midpoint. And again, the more accurate you are with these drawings, the better the results will be. So we're going to find, the midpoint of line BC. Step 2, identify the angle that is subtending that side. So just the angle that's across from it, and that angle is angle A, right up here. And then the last thing, drawing the actual median itself, is start at the vertex and draw a straight line to that midpoint. And again, use straight edges, protractors, rulers. The more accurate these drawings are, the better. One thing you'll notice, unlike some of the other ways that we'll be chopping, the medians will always be completely inside the triangle. Right, so that's the second median, and then if you draw a third one, again, you'll see that there's a pattern happening when we draw all three of a certain kind of line, certain kind of chop of a triangle. The fourth and final way of chopping up these triangles is we're going to be drawing altitudes. For an altitude, the example I like to give to try to remember what it is and how it's different from the other three ways of cutting triangles is to think of mountains, right? Usually we use the word altitude with regard to mountains, and we're talking about how tall a mountain is. Excuse me. So keep that idea in mind, that when we're talking about the altitude, we're talking about how tall a mountain is, or how tall, the height of that mountain. So if we have a mountain range down here, what we mean by altitude is not, this distance, but we want from the tippy top of the mountain straight down to the ground, or sea level. And that's what we're going to do for our triangles. Now, this is probably going to require that you kind of turn your paper so that you can draw the different altitudes. But essentially what you're going to do is you're going to pick a vertex, right? We'll start with this one up here. And you're going to drop a line from that point straight down to the line that's opposite it. Right? So it's kind of right about here. So, and again, using straight edges and perpendiculars. All right? That looks about perpendicular. All right? And then, let's see, we might have to turn this over a little bit. All right, so now I have this line, and then from here, the altitude, I'm going to drop it straight down. Right, make that perpendicular, and then we're going to make our third one. Now, not all triangles are going to have the altitudes inside of the triangle, unlike the median, right? So say we have a triangle like this. Clearly, if I were to drop an altitude from here, it's going to, be inside the triangle. But from here, I can't drop an altitude straight down that's going to hit on this line. So what we're going to have to do is, kind of extend this line out. Oops, let's make it straight though. All right, so this is an extension of the side that's opposite this angle. And then from this vertex, I can drop my perpendicular, or my altitude, I should say. And then you might have to extend that as far as it goes. All right, and so sometimes the vertex will be directly above the opposite side, so dropping the altitude is pretty easy, but sometimes it's not so, and so you have to kind of get creative in order to drop an altitude. But in all of these cases, again, we're thinking about the height of this triangle. If we think of the triangle like a mountain, whenever we drop one of these lines, we're saying that if this was the peak, this would be the height or the altitude of this mountain. So go ahead and, for the last sheet, for all the triangles that are given, draw all three altitudes for all three altitudes of each triangle that's given.